Okay. So the idea is to present INL. INL, probably you know, but I'm going to repeat, is the only intergovernmental institution devoted to nanotechnology in a broad sense. We have right now around 400 employees from 23 countries. So the idea of INL is to use different nanotechnologies for develop application in different fields like food, health, energy, environment, ICT, etc. And our approach is an integrated approach, combining all this knowledge for different purposes. We are young, it's a young institution, but in spite of this, we are performing pretty well in terms of funding and in terms of publication. And we have a strong expertise in sensors, electronics, and the combination of these electronics with different applications in health and in food as well. So why INL is working in food, or what is our aim? Our aim is to develop technologies that we need in the future. So it's estimated that the 70% of the food in the future will be done with technologies that don't exist currently right now. We want to develop technologies to address and to tackle health and well-being. So we are working in functional food, we are working in sustainability, mainly in food packaging, and we are working in an important trend in the future is aging and urbanization, much more related with food personalization. What kind of things we are doing in functional foods? So we are working in oleogel, so how to replace or how to produce healthy fats, solid fats, from to replace saturated fats. We're working in how to modulate by dietary tools the satiety, and we are working how to make much more stable and to improve the bioactivity of bioactives in foods. We are working in packaging in these four fields: biodegradability, active packaging, solutions for edible packaging, and as well to replace plastic, petrol-based plastic, for other solutions like paper. And in personalization, we are working for topics, so to develop organ-on-a-chip tools to evaluate nano compounds, in 3D printing for personalized food, in clean meat, so to replace animal meat protein by non-suffering proteins, non-suffering animal proteins, and in authenticity with solutions that allow us to avoid anti-counterfeiting. Some examples of the kind of things that we are doing. We develop encapsulation and control release solutions for bioactives. So we are working, for example, in pickling emulsions for this delivery of this activity, polyphenols, etc. This is an important part of activities in FODIAC. We are working as well in food packaging in develop nanomaterials to reinforce the barrier properties of these biodegradable materials that are not so good that petrol-based plastic, but as well in coatings. We are a strong activity in different coatings technologies. For example, in this case, for to do super hydrophobic paper, no? In order to replace plastic bags in retailers. In personalization, we're working this 3D printing approach. It's interesting because we are able to modulate the bioactivity in foods by using this additive manufacturing processing, and as well to develop system to test and to check bioactivities of nanomaterials in gut-on-a-chip dynamic models. But as well, we are working on the counterfeiting things. One is related with authenticity. We are working in this combination of electronics and molecular biology technologies in order to develop systems for detecting DNA from pathogens or for different species in order to guarantee safety and security, and solutions like structural color or luminescent stamps in order to to have code bars that communicate with customers and the product. Finally, this is the trends that we want to address. So we're going to work in animal-free meat. So we are developing this printing solution for growing cells, animal cells inside these scaffolds for replace animal meat. We are working in sensors for agriculture, for precision agriculture, for example, to know what is the maturity degree of grapes, or electrochemical sensor for water quality, etc. We are working in the modulation in the brain-gut axis for satiety or other aims. Engineering nanocapsules to achieve this modulation, and of course in biopolymers for replacing petrol-based plastics. For example, in this case for fruits, but we are working as well in solution for cheese, etc. The most interesting thing in an INL is we integrate all this knowledge related with physics, chemistry, biology, food technology, food science in an integrated solution. And this is the mega trends that we want to address in the next year. So everything related with Internet of Things, big data, artificial intelligence, aging population, urbanization, etc., applied to food are or will be topics that we want to address in the future. Well, this is the thing. This is the nano food workers jumping through the future, and this is a whole picture of INL Creo. And that's all. So
now I have understood, because at the beginning I thought I should have presented the results.
No.
FODIAC. Okay.
Yeah, the same as well.
No. So the result of FODIAC is so we can present if you want. We can do another webinar for presenting results. But I think that is in this first round is better to have overview of our institutions, because 2 years later from the beginning, probably we started new projects or new research fields or new topics that could be interesting. For example, in our case, we are starting these clean meat projects related with 3D printing. So it's brand new. We are starting this month this kind of project, and could be interesting to collaborate in how to produce meat without animals, no? So it's one interesting thing. Another thing that started during this period that is brand new for you probably is the gut-on-a-chip. So there are different systems to mimic the gastrointestinal tract, and there are different systems to mimic digestion. So there are protocols like InfoGest and other protocols to do that. But there are not, as far I know, there are not dynamic systems to reproduce the gastrointestinal tract in a very small, in a chip, in a very small space. And this is interesting when we are dealing with nanomaterials that we have only some milligrams. For a steak, it's easy to use the big system for mimic digestion. So there are commercial ones, but this is for a steak. But when you want to know how a nanoparticle or encapsulated polyphenol in a nanoparticle interact with gut cells, how to behave during the gastrointestinal tract, we need to develop this kind of dynamic systems. This is as well brand new. And this Hoyan process to modulate the connection between gut and brain is as well new. So at the beginning of the project, we had not these three lines, no? And it would be interesting for you to explore in the future something related with this, or not, I don't know. So but it's just to show, no? And I am sure that probably you, Paula, or Georgia, or other people, or Jose, probably you are working or doing other things, no? During this time that you want to share, no? This is the idea.
Yes, of course, we have different overlapping competencies and some competencies that are characteristic just of you and that we could be interested in for cooperation. Yes.
For example, probably our friends didn't know, but for example, Georgia and me, we are collaborating with a student, was Alice Groupie, for applying polyphenols.
Not mine.
Sorry?
It was the Alice group, not mine group.
No, the Alice, your student.
Yes, but I was mine because when she presented, we were in the FODIAC meeting when she presented her work, and at the end she said, my group, of course.
Okay.
She did her PhD dissertation last week.
Okay. But it's a combination of 3D printing and polyphenols that was not planned at the beginning. But yes, it's a collaboration that came from the FODIAC, and it's something new. So the idea is to think about and to know, to have this information to develop in the future collaboration. I know that you, Alistair, are doing new things with Paula. I heard about this, no? Probably you can comment something. Or...
We are mute. New things? Not new things, no.
No.
Well, we've got a few developments which may become of interest to people. So we've put several applications into Innovate UK, which are involving apple pumice and a few other things and then there will be polyphenol interest. So we're hoping that some of those things might become of interest to the rest of the group in time. We've got a doctoral training partnership with Reading University, which has only just been announced. That's good news. With Brunel University as well. So that's looking more specifically, that particular project is more looking at energy and LCA work. But it opens up, it should open up some doors, hopefully.
Yeah.
I would be interested in learning more about the 3D, as I've been doing some work on that, and we have a 3D printing machine at Reading as well. So Lorenzo, Georgia, yeah, I'll be happy to, I don't know, perhaps follow up on discussions.
Right. Oh, fantastic. Yes. Well, this is the idea. For today is enough. I need to think about how that ran.
Thank you. It was nice to see you all. Thank you.
Yeah, nice to see you.
Bye.
Good.
Bye.
Bye.
Bye.